of the things we deal with is routing, and we can see that from my choice, it's better to do with AI than human choice. Hello, everyone. In the next 15 minutes, I want to leave with you with one idea. One idea that hopefully you can repeat tonight at dinner, and it will change how you think about where real money in physical AI is going to be made. And the idea is this. The orchestration layer is the missing trillion-dollar piece of physical AI, and almost nobody in the industry is building it. So let me explain what I mean. Today, when we talk about physical AI, we talk about machines, autonomous vehicles, humanoid robots, drones. We talk about making each individual machine smarter, safer, and more capable. Jensen Huang talks about it, we talk about it. Many of the voices that you will hear here across this couple of days will tell you with more authority than I have how to make a single vehicle, a single robot, single connected machine intelligent. And they are right, that work matters, and it is foundational. And it is only half the problem, because the truth is that a single intelligent vehicle doesn't move a city, a single intelligent robot doesn't run a warehouse, a single intelligent drone does not deliver a logistics system. Physical AI at scale, it's not one machine. It's a network of machines, hundreds, thousands, millions, eventually billions, all operating in the same physical space at the same time, generating more real-time data than any human operator can possibly process. And that is where the industry has a blind spot. Every connected vehicle, whether it's a shared scooter in Rome, a rental car in Dubai, an autonomous delivery robot in Singapore, or a humanoid on a factory floor in Stuttgart, every one of them is a node in the physical AI network. The node is being solved, the network is not. So let me share with you a few numbers, because that's what we ultimately care about. A single autonomous vehicle, once deployed at scale, generates between 4 and 10 terabytes of data per day. Multiply that by tens of thousands of vehicles in a city, multiply that by the hundreds largest cities in the world, you are now looking at the data volume that no human dispatcher, no traditional fleet management software, no general purpose AI model can handle. The vehicle can drive itself, more or less. It cannot decide where to be. It cannot decide when to charge, cannot decide which customer to prioritize when 3 requests service within the same minute in 3 different neighborhoods during a thunderstorm while the metro is delayed and a football match just ended 2 blocks away. This is not a driving problem. That is not a hardware problem. It's not a vehicle-level AI problem. That is an orchestration problem. And orchestration at this scale, in the real physical world, requires a very specific kind of intelligence. It requires AI that is aware of space, time, and context. So let me give you a concrete example. Imagine a vehicle in your fleet, a shared car rental, a robotaxi, bigger format. It's currently sitting in a specific neighborhood in a European capital. That neighborhood has certain characteristics. The local metro line is running 10 minutes late. Foot traffic is 40% above the seasonal average for a Tuesday at 6 p.m. A competing operator just moved a couple of vehicles 2 blocks away. A concert is about to end in 45 minutes. The weather is about to turn. Now, a general purpose AI model, even a large, very sophisticated one, cannot reason about this situation. It doesn't know what those signals mean together. It doesn't know which signal matters, which one is noise. It doesn't know that the foot traffic and the metro delay combined will produce a 3x demand spike in that exact corner of the street in 30 minutes. But a domain-specific AI, one that has been trained on the physics and the rhythm of the cities, knows. And more importantly, can decide in real time that your vehicle should move 400 meters west, offer dynamic pricing, and be available at the moment the demand materializes. This is not general AI, it's not a chatbot, it's not a large language model with a plugin. This is embodied intelligence, software that inhabits the physical systems, software that lives in the real world. And let me go one level deeper, because it's the part that most people in our conversations overlook. So the reason AI fails in the physical world is that raw data doesn't mean a lot on its own. A vehicle is not just an ID with GPS coordinates. It has a state, a purpose, a constraint, a relationship to a customer, to a parking rule, to a charging cycle. A street is not just a line on a map. It has a category, a permission, a history of incidents, a typical demand pattern at 7 p.m. on a Wednesday in October. And before any AI can decide what to do, something has to translate the raw signals of the physical world into real meaning. We call this the semantic layer. It takes millions of data points per month from almost 4,000 cities, vehicle pings, trip records, weather events, city signals, regulations, and standardize them, labels them, and gives them meaning. Only then can an AI model reason about them. Without a semantic layer, we don't have physical AI. In urban mobility and logistics, we have a dashboard with a chatbot on top. And there is a second thing that most physical AI approaches underestimate. The instinct is to build one model and deploy it everywhere. One demand forecasting model for Madrid and Munich, Milan. But cities don't work that way. We found with experience that the model trained on Copenhagen by traffic will not perform in Dubai. Model trained on Rome, shared scooters will not perform on Dublin. The patterns are different, the signals are different, the rhythms are different. So we built something else. We built not a single model, but a model generator. For every city we enter and every service we forecast inside that city, our platform generates a model specific to that context. The local mobility patterns, infrastructure, seasonality, the specific service the operator is running. So when a new city comes online, we don't retrofit, we generate. And the accuracy holds because the model was never trying to be universal in the first place. That is what we built at Switch. We built an intelligence layer for urban fleets that gathers data from more than 3,800 cities around the world, processing hundreds of millions of data trips, of data points every month. And we work with shared mobility companies, car rental operators, and logistics platforms. Some of them are names you already know, some names you will know in 5 years. Our platform does two things. The first one is it runs fleets in real time. So we call this Urban CoPilot. What it does is it tells the operator, or in the future, the autonomous vehicle itself, where to go, when to charge, what to charge, and why. In the language of the industry is the operational brain. The second is it simulates fleets before deployment. So we call this Urbiverse. It's a digital twin of the city, detailed enough that a fleet operator or a city government or an investor can run tens of thousands of simulations for a new mobility service before a single vehicle moves, before a single euro of CapEx is deployed. And that is the layer that sits above every connected vehicle in the world. And today, for 99.9% of urban fleets on this planet, it doesn't exist. So why does this matters to this room specifically? To the city governments and policymakers, the fleets moving through your streets are only as smart as the intelligence layer behind them. If that layer lives on a server somewhere, your mobility data, your urban patterns, and the decisions shaping your streets are being made outside of your jurisdiction. If it lives in Europe, Doha, or Riyadh, close to the operators and close to you, you retain the sovereignty that comes with that. To the operators and the OEMs, you already understood this years ago, and we were having some discussions before about this. So the first move was telematics. Instrumenting the vehicle, collecting the data it generates, maybe monetizing them. And that was the right call. It is the reason why you know more about your fleets today than your competitors did a few years ago. The orchestration layer is the next step in that same journey. Telematics told you what your vehicles were doing. The orchestration layer tells you what they should do next. And increasingly, it decides for them. The operators who don't own or integrate this layer in the next 2 or 3 years, not only will lose customers, they will lose the ability to serve them profitably. And to the investors, this is the part I want to say clearly. The global autonomous mobility market is measured in trillions of dollars by 2035, and a very large share of that value is going to whoever owns the orchestration layer. Not the chips, not the vehicles, not the software-defined car, the layer above all of this. And right now the layer is being built in Europe by a small number of teams, which we are one. And the window to shape who owns it, where the returns flow, is open, like our guess is, the next couple of years. After that, the category will be defined, and money will flow at much higher valuations, whoever already won. The European context matters here, because the orchestration layer cannot be a one-size-fits-all product shipped from a single campus. Cities are local, mobility is local, regulation, data is local. And this is a structural advantage for complex existing environments like Europe, and for regions like the GCC that are building mobility infrastructure from a clean slate with sovereign ambitions about the data and the intelligence that will run them. So let me go back to where I started. The machines are getting smarter, that is happening. It is inevitable. Many of the voices that we hear here told us so and will tell us so, and they are right. And smart machines without an orchestration layer are just really expensive hardware. And the trillion-dollar piece of physical AI in urban mobility and logistics, it's not the robot, it's not the chip, it's the layer that turns thousands of connected machines of nodes into one intelligent system. That layer is the brain of the physical AI economy, and it doesn't exist yet at scale. The window to build it, to invest in it, to decide where it lives is right now. So if you run a city, the question is whether the fleets moving through your streets are coordinated by intelligence that understands your context, or by intelligence that treats your city as just another data point. If you run a fleet, the question is whether the intelligence layer you operate on was built for your scale, your complexity, and your margins, or whether you're going to spend the next 5 years trying to build it yourself while your competitors move faster. And finally, if you invest capital, the question is whether you want to be early in this next trillion-dollar infrastructure category, or whether you want to read about it in a few years on the front page of Bloomberg. So I'm here for all of these conversation this couple of days. You can find me here. Thank you.